For this video, we want to go over the reaction mechanism for hydrohalogenation of alkynes. So we can take a look at a generic alkyne like this. That would be our terminal alkyne, or we could have a internal alkyne. So the one that we're going to take a look at is a terminal alkyne. And so we're going to take, I'm going to draw it like this. Like so. And hydrohalogenation is when you take and treat it with, let's say, HBr. That's going to give us a compound that looks like this. Double bonded C, and we're going to add two hydrogens there and the bromine right there. And then if we do it again with another equivalent of HBr, we're going to add another one to the same carbon to which the first bromine went to, like this. And then we will also add another hydrogen to the same carbon that the previous hydrogen went to, like that. So we can do this mechanistically, like so. Okay, the pen is going out here. Give me a second to get this to, there we go. So if we treat that with HBr, the hydrogen here is very electron poor. We have an alkyne, very electron rich. So we will take that electron rich pi electrons, come and abstract that proton, and break the hydrogen bromine bond. But recall that bromine already has 3 lone pairs, like so. And so what's the product of that going to look like? Well, we are going to add, so that hydrogen was already there. So this hydrogen, let's change it to green so we can keep track of it. Where's that hydrogen going to go? Is it going to go to carbon 1 or carbon 2? Well, we saw that it went to carbon 2, and the reason why is it's going to follow Markovnikov's rule. And if we put the hydrogen there, we will then just change the angle here, that black hydrogen. Why does that happen? Because it's going to make this a carbocation that's more substituted with the alkyl group. That's just going to give us a more stabilized carbocation. And then we're going to have our bromide that was right, that came from right there. And so that's going to be negatively charged. And so our next step then is going to be the bromide is going to take one of its lone pairs, come in and attack like so. And that's going to give us something that looks like this. And green hydrogen there. Now we can do this all over again with another equivalent of HBr. And this HBr, let's put a blue hydrogen, like so. Very similar mechanism. That's going to come grab it. That's going to break. But we already know that there's 3 lone pairs already on that bromine. And so that is going to now give us a species, the bromide species. It's going to be negatively charged. And we're going to generate another carbocation. So the green one, still there. And now what did we do? We added another hydrogen, represented by the blue one. Now, why did the hydrogen go to that carbon? It's following the Markovnikov rule again, because that's going to generate a more stable carbocation. And so the last step then is the bromide's going to come in and attack to generate our final product. That looks like this. Br, carbon, hydrogen, our blue one there, and our green one there, like that. So this is a hydrohalogenation of alkynes.